क्लास स्टार्ट हुआ। A very good afternoon to all. So today we will see about transducers for biomedical applications. So from the last 1 week we are seeing different types of transducers like active transducers, passive transducers. So active transducers does not require any excitation sources. Similarly, for passive transducers, we require some external voltage or excitation voltage to get the change in to identify the variation of the parameter. So like that we have active and passive transducers. In passive transducers we are using passive circuit elements and active circuit elements. Passive circuit elements are resistive, inductive and capacitance circuit elements or capacitive circuit elements are used, and these are used as a passive transducers. And similarly for active transducers, so we are using vacuum tubes and transistors or active circuit elements, and these are used to get the conversion of photon energy into the electrical energy. So like that we have number of active and passive transducers which converts one form of energy into another form of energy. So most of the cases in the electrical form of energy we are seeing as the output. So that obtained output voltage or current are uh, used to measure some instruments by using meters or bridge circuits. Like that we can use and we can identify the variation of these parameters. So generally coming to what are the different types of transducers which are applied for the biomedical applications. So now I am showing some of these slides. So here these are some of the transducers mainly used for biomedical applications. So force measurement or pressure measurement, piezoelectric transducers and unbonded strain gauge. So here it is piezoelectric transducer is the active transducer and unbonded strain gauge is a passive transducer. And coming to displacement measurement, there are variable resistance type, variable capacitance type, variable inductance type, and LVDT. These transducers are used for the measurement of displacement. And next, coming to surface strain gauge is used. Surface strain. And coming to velocity, magnetic induction type of transducer you can use. And temperature, thermocouple, thermistors, and also you can have RTD, light, photovoltaic cell, and photoresistor type of the transducers. In this, photovoltaic cell is a active transducer, and photoresistor type transducer is a passive transducer. And in temperature, thermocouple is active transducer, and thermistor and RTD are passive transducers. Okay, so but the main variables which are required to measure for the biomedical applications are pressure and fluid or gas flow and temperature. Suppose to measure the pressure BP, so that is a pressure measurement, and to know the blood flow, what are the fluid flowing, how much rate it is going in the body, like our blood, how much flow it is moving. So that can be measured by fluid or gas flow rates. Okay, and also we can measure the temperature. So for measurement of the temperature, uh, we have thermometers. Okay, thermometer, by using thermometer we can measure the temperature of the human body. So, but to measure the pressure, uh, we have the BP measurement. So where but to know the perfect continuous measurement, it is not possible by using um, BP measurement generally seen in hospitals. Okay, just instantaneous pressure we can measure. But to measure the continuous measurement and to know the continuous fluid flow, so we have present set transducers are not suitable. So because to measure the fluid flow, we have to insert the sensor into the human body. We have to insert the sensor into the human body. That makes effect on that makes effect on the patient. Okay. Similarly, we have to uh, know the continuous pressure. So uh, there is the sensor should be contact with the blood flow. So these are not possible. So for that purpose, we have to use another type of transducers. So that is the first one is force transducers. Force transducers are used as to first of all, the force applied force will be converted into the displacement. Okay, first of all, we have a this is here. This is a force summing movement. So this is the fixed body. So over we have a leaf leaf spring. This is leaf spring, and this entire arrangement is called as a force summing member. Force summing member. So when the force is applied at the end of this leaf spring, so it makes a deflection of or displacement some x. So that displacement will be easily measured what we are having previous transducers. So first of all, we have to convert the applied force into displacement. So force to displacement conversion. After that, displacement is converted into the electrical form of energy. So for for that purpose, we are using this force sum force summing membrane. Okay. So coming to uh, this is force summing using bonded strain gauge. Okay. So here we will fix a strain gauge one upon the other. So here this is the leaf spring. Okay. So over that we will fix the two strain gauges. So with this we will measure the surface strain. So two strain gauges are bonded to the leaf spring. Okay. So when the force is applied, this spring will be moved to downward direction, and due to that, the resistance or the upper strain gauge will be expanded and lower strain gauge will be compressed, and due to that, the variation of the resistance will be measured using Wheatstone bridge. Similarly, coming to force transducer using differential transformer. So what we studied in LVDT. So LVDT, this is the LVDT, and inside we have a core, and this core is attached to leaf spring. When the force is applied, this leaf spring will be moves downward direction, and this force will be converted into displacement. That displacement, obtained displacement, will be measured by using LVDT, differential transformer. So here the amount of the force which is applied will be measured by using force summing member as well as the LVDT. So force will be converted into displacement, and that displacement will be converted into electrical form of energy. So here there are two types of conversions. One is force to displacement, and another one is displacement into electrical form of energy. And another one is This is the force transducer using lamp, and photoresistor. So here, this is the lamp and this is the photoresistor. And here this is a shutter. Shutter does not allow the light to fall on the photoresistor. This is the photoresistor. So when the force summing member will be moves downwards, when the force is applied, the force summing member or leaf spring will be moves downward direction. That amount of displacement will be applies to the shutter, and shutter will be moves downward direction, and it will be blocks or stops the light falls on the photoresistor. So the amount of the current which the amount of light falls on the transistor will be measured in using some measuring device at the output side. So when the lamp falls on the photoresistor, initially suppose assume that the shutter is not covered any light, then we have certain amount of the current depending upon the light intensity. If the force is applied, the shutter will comes down, and due to that some of the light will be stopped, and some more light will be falls on the photoresistor, and due to that the amount of the current flowing through this resistor will be changes. That will be measured some output measuring device. Okay, so like this we can convert the force into displacement and displacement into electrical form by using photoresistor device. So like this we have a number of force measuring devices or force transducers. Okay, directly cannot measure the force, so that force will be converted into displacement, and displacement will be converted into electrical form by using our known passive transducers. And transducers for displacement, velocity and acceleration. So all of you know that. So displacement is the uh, derivative of the displacement is the velocity, and the derivative of the velocity is the acceleration, and we can also write that double derivative of the displacement is the acceleration. And similarly inverse of this one is integration of velocity is the displacement, and double integration of the acceleration is the displacement. Okay, so if suppose we can measure any one of the parameter, suppose we can measure displacement, so from this displacement we can measure the velocity, we can measure the acceleration. So and from that we can find the so if any one parameter we know, so from that we can measure the other two parameters. We can obtain the other two parameters. So part of the transducer is attached to the body structure to measure the displacement, and the reference point is to be available. So these these conditions cannot be always be met in biomedical applications. So indirect measurements are used in such situations. Here what I am saying is, so uh, reference points also required. So here, so direct part of the transducer is to be attached to the body structure to measure the displacement, velocity and acceleration. So okay, so and also we have to require some reference point also. So these two conditions are not possible. So we can go to indirect measurements for the measurement of the displacement, velocity and acceleration. And these are the contactless methods. Contactless methods for measuring the displacement, velocity um, based on optical and magnetic principles are occasionally used. So generally contactless methods are optical methods. Magnetic methods, it is required a small magnet which is to be attached to the body to use the magnetic methods, and place a metal to the attached to the structure of the body. So ultrasound methods are used most of the more frequently. So ultrasound methods are used and optical methods are used. So most of the cases, optical methods and magnetic principles. These are mainly used for uh, these are while using these methods there is no uh, not inserting of the sensor to the body structure, not inserting to the body structure. So optical methods and magnetic principles and ultrasonic methods, these are contactless methods. So we are not touch the body, we are not touch the body to measure these parameters just like a pressure and fluid flows. Okay, so ultrasonic methods are used to know the ultrasonic methods are used to um, know the what are the conditions, how what are the blood flows are there. So to know the is health conditions, suppose we have to know the uh, um, growth rate of a baby inside a mother's womb. So we can use the ultrasonic methods, so we can easily identify the how the growth rate is there. So in such situation we are not placing any sensor to the body structure. Okay, so like that these ultrasonic methods and like that MRI and CT, these are very useful, and these are contactless methods uh, are used. Okay, and coming to pressure transducers. So these are some of the pressure transducers which are used to measure the pressure. So this is a we can say it is a flat diaphragm, force summing members. This is also force summing members, force summing members. See here, this is closed one, and here we have a open. When the pressure is applied, so it will exert a pressure on the, this is the diaphragm, on the diaphragm. This is diaphragm. When the pressure is applied, this diaphragm will be expanded like this. So there is a displacement is there. There is some displacement is appears on the diaphragm, and due to that, the applied pressure will be converted into the displacement, and that change in displacement will be measured our well-known displacement transducers. Okay, this is the flat diaphragm, and coming to corrugated diaphragm. So this is corrugated diaphragm. So there is one. This is the formation of the corrugated diaphragm. We can call this the corrugated. So there is some variation. It is not a flat. When the pressure is applied, this corrugated diaphragm will be also varies according to its structure. Okay, and it also having some displacement by the application of the pressure, and that change in the displacement will be measured using displacement transducers. And coming to another one, Bourdon tube. So the first two, one flat diaphragm and corrugated diaphragm, both are used for measurement of small pressures. So these are used for the small pressure. So whereas to measure the high pressure range, we can go for the Bourdon tube. We can go for the Bourdon tube. So here we have a extendable end. This is the movable end, and this is the fixed end and movable end. So when we apply the pressure, this C-shaped Bourdon tube will be expands, and there is some displacement will be occurs here. This displacement, this the dotted line will indicates the displacement from this place to this place, right? So that variation of the displacement will be identified by using displacement transducers. Like this, we have pressure transducers, generally used for the measurement of pressure. Once again. Okay. A small break. I will take the attendance. Please stay on the line. The participants are very less. So like this we have number of transducers which are used for the biomedical applications. So force transducers, pressure transducers, uh, and transducers for displacement and velocity acceleration we are using. For the especially for biomedical applications, and these are directly will not measure. So okay, you have to convert that the force into corresponding uh, linear displacement or displacement, and from that we will get the value of the displacement value, and the displacement will value will be, we will convert into the actual upward force. Okay, so these transducers, uh, inductive transducers, capacitor transducers, and resistor transducers, active transducers. Okay, so we have to know the principles of each one, and according to that we can apply the where it is required. Okay, so this is a photo multiplier tube. So in place of, in previously we are saying that photoresistor. So in place of photoresistor, we can use this multiplier tube to get the higher light intensity, higher light sensitive, because the light sensitivity of this photo multiplier tube is very high. Okay, to know the light incident light, and these are the some of the sensors we can use. If anyone is newly joined, if anyone is newly joined, please give a roll number and chart. After I was taken the attendance. So in the coming classes, we will see the different pulse sensors. So how we can measure the oxygen pulse rate. So using pulse sensors, and these are also having different types of principles for using photoelectric pulse transducer, piezoelectric pulse transducer, strain gauge pulse transducers, like that. And after that, we'll see the respiration sensors. Respiration sensors. So in this we have strain gauge type chest transducer, the administered basic transducers, and after that the transducers with digital output. Okay. So with this we will finish the second unit. So the pulse sensors we will see in the next class. Different types of pulse transducers. If you have any doubts regarding up to now, so you can put message in charts. If there is any clarifications are required. So how was the voice and how was the presentations? If there is any not understanding the principles, you can put the chart, you can write in the chart. Still any doubts? All right, good. 2 minutes, 2 minutes. Okay. So with this, I am closing the session. Today's session. We will start the pulse sensors and respiration sensors from tomorrow class. Thank you and all.